Hi guys, it's me, Krubase. Today I'm going to walk through another paper, P2, 15 October 2024. I have never seen the paper before, so this is going to be a live walkthrough. The reason why I'm doing this is because so that you guys will know how I approach the paper unseen, under the real exam conditions. So I'll be timing myself for an hour and a half, and I'll tell you my thought process as I do the paper. And after I hit the timer, there'll be no cuts, no edits. So the timer has started. Okay. Question 1. All right. So we have a table there. Seems like this is a trapezium rule in P2. Okay. So a table with y equals fx gives you all the x and the y already. That's good. Using the trapezium rule with all the values of the y given in the table, find the estimate for that. So just be careful here. We are integrating from 0.5 to 5.5. That's just everything in the table. So we can find the trapezium area. So this will be an estimate, guys. It is just half times the width between each strip. So it's like the distance between the x values. And that should be equal, right? So as you can see, it is increasing by 1.25. If you do the math there, you just subtract the next one by the previous one. So I'm just going to do 1.25 here. And that's the height of the trapeziums. And then in the large brackets here, we're just going to do the first one plus the last one. So the first y, 3.479, plus the last y, which is 5.182. And then plus all the other ones will be multiplied all together by 2. So we add them up first, like that. And then that would be the area of the trapezium. I'm just writing quite large here. Okay, just checking if I get the numbers all correct here, because I've seen many people making that mistakes, copying numbers incorrectly. All right, so that would be the estimate. I'm just going to use a calculator here, guys, because I don't think anyone would want to do mental math on that, right? Okay, so yeah, so outside the twos there, I have 3.479 plus 5.182, and then plus 2 multiplied with the brackets here, 6.101 plus 7.448 plus 6.823. Just checking the calculator if I put everything in correctly again. Okay. That should all be okay, right? So I have an extra 3 there somehow. Okay. And then the closing the brackets and then the brackets there. So I have about 30.1 decimal place. So we have 30.878 blah blah blah. So I'm just going to write 30.9 there as the final answer for A. For B, using the answer to part A and making your method clear, yeah, this comes up quite a lot. So it is integrating not just fx, but also 4x. So just going to have to write down here so you can see what we are doing. If we split the integral there, we're going to have this plus with another set of integration, but with the same limits, right? The same bound. So it's basically just integrating 4x using the same upper and lower bounds. So this is easy because we already know that this first term is 30.9, right? Yeah. And the second term, we're just going to manually do the integration, right? There's no big deal there. So it's just integrating 4x, yeah? So it's 4x to the 2 divided by 2. All right. And I'm just going to maybe delete so I don't have to write the next line. Okay. Just 2 there. And I have the bounds here to be 0.5 to 5.5. All right. So again, I'm just going to use a calculator here to just calculate everything. So I have here in the calculator, hang on, that's adds, again adds. So we would have 30.9 here, sorry, plus. So I can do this, yeah? I'll show you my technique, even if I'm using a calculator. So the substitution, the upper and lower bound, you don't need to substitute like over again every time. So here, if you bring the 2 out, I can just do 5.5 squared and then minus 0.5 squared. That is also going to work because you're just taking the 2 out and then you just sub the x squared basically. So I'm just going to cancel that out and 90.9 as my final answer. So that was nice and easy. Number 2. A sequence of number u1, u2, and u3 is defined by, so this is a sequence relation. It may not be arithmetic or geometric. It can be anything, but let's see. So u1 is 7, un plus 1 is whatever that relation is. We show that u5 is 7. All right. So if u1 is 7, then u2 would be equal to that relation there, which is, what is it? Minus 1. So in this case, if we want 2 on the left here, n would have to be 1, just to make that 2. So n would have to be 1 there. So this is u1 plus k. Okay? So there you go. So we have u2 being equal to what? Minus u1 plus k. Yeah? Just keep with that there. And we do u3. So u3 is going to take the same pattern. It's going to be minus 1 to the 2 because now n is going to be 2 there. And this is going to be u2, yeah, plus k again. But because we already know that u2 is minus u1 plus k, right? And this minus 1 squared is going to be 1. So I'm just substituting u2 in the front term there. So minus u1 plus k plus k. So that will give me minus u1 plus 2k. So as you can see, we are getting more and more k's as we progress down the sequence. So u4 equals minus 1 to the 3 times u3, yeah, plus k. So that would be what? Now this time you get a minus u3. So I do minus, and then u3, the whole u3 is just minus u1 plus 2k again, plus another k. Now, as you can see, k gets subtracted this time, right? Because we have a plus u1 here if you expand the minus sign into the brackets, but we have minus 2k with also a plus k outside. So we actually get a u1 minus k. Now for u5, right? So it's minus 1 to the 4, and then u4 plus k. But minus 1 to the 4 is basically 1. u4 is u1 minus k and plus k here. So this is u1. Oh, so it comes back to u1. So therefore, this is 7, right? So as required. Yeah, because we know that u1 is 7. All right. So basically it. So you see, I didn't quite substitute u1 there. Honestly, I forgot to do that. But I realized later that, we got u1. So I just did that. Right. So that's fine. So that was A. Now let's do B. Given that that sum is 30, so that sum, you gotta be able to understand the notation, guys, because sometimes if you don't, then maybe you're in trouble. So in this case, it means that you're gonna have to go from R being 1 to R being 4. So that's basically the sum of u1 plus u2 plus u3 plus u4. That's basically what it says. Being equal to 30. Yeah, that's given. So we're going to take all the u's here from 1 down to 4 and then add up to 30. So u1, we are given, that's 7. u2 is just minus 7 plus k. So that is plus a minus 7 plus k. I'm just going to keep writing down first. Yeah, although I know that they can cancel now, but just for, reference. Now u3 is minus u1 plus 2k, minus u1 plus 2k. Yeah, and u4, just squeezing a little bit here. u4 would be u1 minus k, so that's 7 minus k. Yeah, so that's done, right? Because we don't need u5. And all of this is equal to 30. So let's do some algebra here. So 7 cut 7 there, 7 here, cut 7 here. So we have 3k from these two terms and a minus k. So that's actually 2k equals 30. That means k equals 15. All right. Well, yeah, I think that's it because I probably didn't make any mistake in A. Otherwise, I wouldn't have got 7 here. And all of that is fine. Yeah, I think I'm fine with that. So k is 15. And C, hence find value of u from 1 to 150. All right, so that's interesting, don't you think? So look, if u5 becomes 7, don't you think that the next one, which is u6, don't you think it's going to repeat the same pattern when u1 goes to u2? So u17 going to u2, it gets minus 7 plus k. It's going to have to be the same, right? So that means we are grouping 150 terms into groups of 4, where those groups have the same sum, right? So u1 plus 2u4 is already known, is already given, actually 30. That means if you go from u1 to u150, there will be many groups at least. Well, the easiest way is because we know that there are groups of 4, but maybe some remainders. So if we do 150 divided by 4, we get what? We get 3, and then wait, what? 4 times 3 is 12. That should be 7. So it's 37, right? Yeah, and remainder 2. Yeah, so I just write R2 here. Is that right? 3, 12, 7. Yeah, I'm just checking. So there are 70. So the sum, just writing down here, from 1 to 150, UR equals. So that's going to be equal to 70 groups, sorry, 37 groups, where each has the sum of 30. And then the remainder of 2, so the remainder would be the first 2. The remainder of 2 here would be the first 2 terms, which is U1 and U2. So U1 being 7, and U2 would be minus 7 plus k. So minus 7 and a plus k, where k is 15 from the previous part. So that would be, so that is 0, 1, 2, 8, right? No, hang on. 0, 1, yeah, so that's it. This is canceling out, and we get 15 there. So this is 1, 1, 2, 5. Yeah, so just making sure if I didn't do any wrong mental math there. Yeah. Okay, yeah. So this should be fine. All right, guys. So that is my worked solution for question 2 live. Yeah, because I've never seen it. Next, question 3. All right. So we have this polynomial function where a and b are unknowns, but they're integers. Given that when f(x) is divided by x plus 3, the remainder is that. Okay, so this is remainder theorem. Okay, so we take the critical value of x plus 3 factor there. The critical value is just if you put x plus 3 equals 0, it is quite easy to know that it should be minus 3. People recognize it already. I'm just going to write it anyway to show my thought process there. So we're going to substitute minus 3 into the x's in the polynomial function and equate that to 55 because this is the remainder theorem. If you substitute the critical value into the function, you get the remainder. So I'm just writing the left-hand side here, 2, and then minus 3 to the 3 minus, that's a minus, yeah, minus 3 to the 2 plus a minus 3a, yeah, and plus b equals 55. So that's one of them. And we're going to somehow simplify and get the required form there. Seems like the 3a and the b are in the right place because we don't need to do anything to them. Maybe I'm going to move these two to the other side. On the right side, I get 3a minus b, right? The whole lot of the 3a and b there. And 55 would be moved to the left. So what do I get here in totality? So I get that's minus 27. So this is minus 54. This is 9, and then minus 9 here. and minus 55. Yeah, that seems to be, yeah, 108, 18, sorry. Is it? Yeah, 109, yeah. So therefore, I got what is required. There you go. So that's A. B, given also that 2x minus 5 is a factor, find the value of A and the value of B. So again, this is just factor theorem. So instead of, yeah, getting a remainder of something, we get a remainder of 0. But the critical value, we got to be careful. The critical value is not 5. It's actually 5/2. So if you stick to the real reason why we use critical value, because we are putting this equals 0 first, the critical value here, in this case, become 5/2. So we do f of 5/2. Yeah, substitute everything in again, and we should get 0 this time too. 5/2 to the power of 3 minus 5/2 squared plus a of 5/2 plus b. This should all be 0. All right. So just trying to do mental math there again, just for fun, guys. So this is 125 because 5 to the 3 is that. And then we have the 8 down here. So cutting with 2, we have the 4. And this is minus 25/4 if you square that, plus 5/2a, and then plus b equals 0. Okay, let's see. Yeah. You see, I have a minus b here and a b here. I'm expecting that I should add these two equations up, right? But let's simplify the math here first. So we get 100. Okay, these two together should give me 25 because that's 100/4. So this is, and after getting 25, I'm going to move that to the left, to the right side of the equation. So I'm left with this, yeah? Moving everything to the right side. Now we're going to add these two equations, right? We're going to add them up. So I'm just going to write them down again for the other one. We're adding them up just like column, guys. So we get 0 b's, but then these two, 5/2 with 3, what do you get? 11/2 there for A, right? So it's 6/2 at 5/2. Yeah. B goes away, and then what is this? 3, 4, 1. Just do column there. Okay. And seems like I can simplify because I know that 11 can divide that. So I get 1 there and 1, 3 there. So A would be 26. If A is 26, then B would be equal to, maybe using the easier one, maybe this one. So that would be 3 of A, and then I move B to the right and minus 118 to the left. I should have a plus 118 here. It's like I'm switching the sides as well, okay, making B the subject. So what is that? That is, let me use a calculator, guys. Okay, maybe mental math is going to take some time there. Okay, so A is that and B is 196, right? Okay, B is done. And C, hence find the quotient when fx is divided by x minus 7. So we should update fx first. After getting everything, we have this, and A is 26, and B is 196. So we're going to divide that, right? Find the quotient. So the quotient can be done, can be found by just a long division. So we're going to just do a long division maybe, because the trick won't maybe get you method marks. So we're not going to risk that. So yeah. Okay, so we are dividing long division here. Okay, so first term divide into the first term, we get 2x squared, right? And 2x squared, multiply that back, we get 2x cubed minus 14x squared. Subtracting these two lines, we get that should go to 0 anyway, the first terms, but that is minus x squared minus 14x squared. So we get a 13x squared. Just have to be careful with the sign. Pulling 26x down and then doing the division again. So first term divide into the first term, we get a plus a 13x here. So a 13x squared here should be obtained there. 13 multiplied minus 7 should give me minus 91x. Yep. Subtracting these two lines again, we get 26 minus 91. So we should get all of them added. So 7 and 1 here for the x. Pulling 196 down. Yeah. And then first term into the first term, I get plus 117 here. That's a huge number somehow. Not so sure with that now. Yeah. I think a quotient means it doesn't have to be, the remainder doesn't have to be 0. So yeah, we can check back about this later. But 117 times 7 is 891. So that's minus 891 because I didn't forget about the minus sign there. And then I'm going to do that. So 196 minus 891. So that becomes a plus 196 there. Okay, so this is the remainder of that. So the quotient is equal to just the top part. Okay, there you go. Now I'm in a bit of doubt about my working here because, I mean, to me, this remainder is huge, right? So maybe I make a mistake somewhere. So I'm gonna check back to this, right? Because hang on, we managed to get that, but maybe we need to check about this one again. Yeah, let's come back to check about this one later. Number 4. Number 4, we have the equation of some curve there. Find dy by dx, giving each term in the simplest form. Okay, so dy by dx for A. Let's zoom in a little bit more there. Okay, so again, this is easy. So when we differentiate a polynomial, we bring the power down, subtract the power by 1. So bring the power down, multiplying with 4, we get 2. Subtract the power, so that becomes a minus 1 over 2. Again, the second term, bringing the power down, we get a minus 9 over 2 instead. And subtract the power, we get that. That's number 3. And then that goes to 0. All right, just zooming back out. Okay. Simplified each term. That's already simplified to me. All right, so B. Hence, find the x-coordinate of the stationary point. Again, the stationary point, we put dy by dx equals 0. So I'm just going to write that already. And seems like we have to solve this equation to find the stationary. Seems like there's only one point because it doesn't have any plural form there in the words. So because one side is already 0, I can do, maybe I can do moving 9 over 2 x to the minus 3 over 2 on the other side because it's a minus sign. So I would like to do that. And well, you can just rearrange moving numbers to numbers on the same side and moving the x term on the same side. So I move 2 down here. I get it's like dividing 2 both sides. So I get 9 over 4 here. And then x to the minus 1/2 here. So after you have moved this to divide the other side, it will become something that is dividing, right? And when you collect the index there, like use laws of indices, you will see that the power must be a minus. So we do minus and then minus 3 over 2 there. All right, just wrapping up. So minus 1/2 minus 3 over 2, you're going to get plus 3 over 2. So that becomes 2 over 2. So that is actually 1. And that is actually the answer. Okay, that's x-coordinate of C. All right, x-coordinate of C, yeah? Stationary point. No, just C, yeah. All right. Next one, C. CI. Find d squared y by dx squared. So that's called the second derivative. Okay, so second derivative is obtained by differentiating the first derivative. Okay, so we're going to differentiate this whole lot. So that's going to be, again, bringing the power down. We have a minus 1 over 2 times 2, so that's a minus 1. And then power subtracted by 1, I get minus 3 over 2 there. So for the second term, a minus 3 over 2 multiply a 9 over 2, I get a plus. So that should be 27 on the top and 4 at the bottom because they are two fractions multiplied. The power gets subtracted by 1. So we have a minus 5 over 2 instead. And that is just it. Okay, so the second part, hence determine the nature of the stationary point of C, giving a reason for your answer. So basically we try sub, so this is how you write the notation if you want to do it. You sub x equals the previous answer here. Yeah, so we're going to sub x coordinate into the second derivative function there and see what we get. Okay, so okay, I'm just going to write down the substitution here first. But that can be tricky when you put in a calculator. Okay, so I'm just going to do this, guys. I'm going to do 9 over 4 and then equals to store my answer. No, hang on. 9 over 4. This is not 9 over 4. Is somehow I added a minus. That's not good. Yeah. So 9 over 4 and then stored and then clear that. So I'm going to do minus answer to the power of minus 3 over 2. And then plus 27 over 4 multiplied answer to the power of minus 5 over 2. Because I don't want to do too many 9 over 4s, so I'm just skipping that by just storing it to an answer first. I mean, it would be more obviously useful if you have longer functions. So here, I think that's the answer. Now we get 0.9592 blah, 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 which is greater than 0. So this is telling you that the stationary point is a minimum, right? Yeah, greater than 0 means that the rate of change is like increasing. So we have a minimum there at that point. Okay, so that's minimum as dy by dx squared, d squared y by dx squared greater than 0. So minimum, all right? And then d, state the range of values for x for which y is decreasing. Y is decreasing means that dy by dx is less than 0. So it's like a negative gradient. Yeah, it's the part of the function where the gradient is negative. It means that y is decreasing. So dy by dx, we gotta take back what we did here. Okay, so that means the first derivative, which is that, what we got earlier up here. Yeah, I'm just copying here. See if I copy that right. Blah, blah, blah. Yeah, less than 0. And we want to solve this inequality to get the range of x values. And we got to be careful when we solve this inequality, right? So maybe what we can do is multiply by some x to the power of something so that we can cancel the denominator there. Sorry, the fractional power. So what about if I multiply by x to the 1 over 2? No, maybe 3 over 2. Yeah, how about that? So if we multiply by x to the 3 over 2, that is supposed to be, because x is greater than 0, so this should be greater than 0. So we have no problem with multiplying an inequality there because that's not going to flip my sign. So if I multiply that out, so I'm going to get that just 2x, because if you add up the powers there, it becomes 2 over 2, so that's just 1, okay, for the first term. And then for the second term, that goes away, and I get only that, okay? So this is just 2x less than 9 over 2, so that means x less than 9. Sorry, 9 over 4. You got to move 2 down to multiply the other 2 there. So that is just it. But it got to be greater than 0 as well. Okay, so I mean, greater than 0 is trivial because it's already given. So I'm just going to go with that. Okay, so that's my number 4 done. Next, number 5. Just going to do here maybe. Find in terms of A, the first three terms in ascending powers of X of the binomial expansion that. This is just normal binomial expansion where you can use, so it's like A plus B to the N. It's like the summation of the first term starting from 0 to N of the coefficient, binomial coefficient, being Rn here, and then a to the n minus r times b to the r, right? So there will be multiple terms from the first term where I is 0 to the last term where I is n. And each term we have binomial coefficient, the a to the power of something, b to the power of something, right? So it is the first three terms. So we just do, so the first term, r being 0. So 0, it's quite obvious that we're going to have to do 2 to the 6 for that, okay? And the next term, we just have, so this is 6, 1, right? So this is I equals 0 here on the first term. When you put I equals 0 and n is whatever, you're going to get 1. So that doesn't quite affect anything. But here n is 6, right? So we're going to have, hang on, let me just write that. Okay. So that's the first term, and then ascending power, yeah. So this is ascending power. Yeah, that should be fine. 6, 6c1, and then a to the power of, a is 2 now, to the power of 5. So the power will get, the power of the first term here will get smaller and smaller, where the power of the second term, which is the whole lot of ax, will get bigger and bigger. So from 0 in the first term, I get a 1. And then the last term would be 6, 2 here, 2 to the 4, and then ax to the 2 instead. We already got the first three terms, so we are fine. So 2 to the 6 is 64, yeah, because that's 8 to the 2. 6c1 is just 6. 6 multiplied 32 is 192, right? Yeah, 6, 192 ax, because that's not powering anything, right? And then the third term, well, we got 6c2. Well, I happen to know that it's just 6 multiplied 5 and divide by 2. That would be 15. 15 multiplied 2 to the 4, which is 16. Yeah, so I get 240. A to the 2 x squared. So that is my simplified form for that. Okay? Yeah. And then that's just A done, I think. So B, what do we have? Given that the constant term in the expansion of fx is that, okay? So the constant term, we already have this, right? So we're going to take all this because it says the earlier binomial expansion, that at power of 6, multiply the new term there. So I'm just going to do that. Multiply just up to that because, yeah, we already did up to the third term. But let's see, because I'm just going to do that. So if you square this, what are you going to get? You get 9 for the first term, 2 times 3 times 1 over x. So that's going to be 6 over x. So yeah, I'm using a plus b squared. It is faster if you remember this, because I've seen my students having to expand manually all the time. But if you remember this, it's faster because I'm doing this right now. And the last term being 1 over x squared. So that's 1 over x squared down here. And all that again, right? Now look, we want the constant term only. So we are not focusing on any other terms, right? So for example, how do you get constant term? You need to map. You need to match 9 and 64. You need to also match 6 over x and that term. And also this guy, right? So there are actually 3 pairs and no more. Because, for example, if you take 9 to other terms, you get x's now. 6 over x to other terms, you also get 6. Even 6 over x to this term, you get over x down there. So that's not going to give you a constant term. which is what it wants there, right? So the constant term here being 9 times 64 plus, yeah, that's the first pair. The second pair is x will cancel there. The reason why this pair will work because x will cancel that when you multiply them, right? So I'm only left with 6 multiplied 192 multiplied a. The x's go away because they cancel out. And then the third pair would be, again, this is 1 over x squared, going to cancel out with the other x squared here. So I'm only left with 240 a squared. That's what it is. That's all we need. And then we equate this to 576 because it is given here that the constant term is summed up to that. Okay. And then we want to find the value of a. So this is, okay. This is quadratic, right? So can we simplify by anything? Because I don't have a quadratic solver in my calculator, so I need to do that. So I have 240 a squared, and the a term is 192 times 6. I get quite a large number there, 1152a. And then here I have 9 times 64, and then have to minus 576. Ooh, lucky me, I get 0. So that's just equals 0. Okay, so lucky because now I don't have to do quadratic formula anymore because I know that it can be factorized like that, and one of the a is 0, the other one being minus 1152 over 240. Now, can a be a negative value? Yeah, seems like it can. It doesn't say anything that it cannot be, but a is a non-zero constant, so we cannot take that. That means that is the, can we simplify that? 1152 over 240. We got 4.8. So 4.8 is 48 over 10. So that's 24 over 5. My calculator just doesn't give a fraction. So I have to do that by myself. So that's 4 minus 4.8. All right. So that is the answer to that. Next one, question 6. We are at quite good pace here. Using the laws of logarithms, solve that. We gotta be careful with logs, all right? But we gotta solve that first. All right. So I'm just gonna bring the other log term on the right side to the left side. So I get that. Now, the 2 here can be pulled to be the power of that argument, right? So using the log property that you should know watching this video, yeah, like if I have an n, so I'm just going to write the property here, n log b maybe, so we can pull the n up to the log, so we have b to the n instead. Yeah, so that can be turned to that. Okay, just for your reference. And then what did we do now? Okay, we put 2 up there, and then number 2 is still on the right side of the equation. All right, we just move that term to the left. All right, and then the reason why I did the 2 here, because we want to merge these two logs using what? Log A minus log B, right? That would be log A over B, yeah? That's another log property there. So this is, I'm going to get 12 minus 2x, right? Over x plus 1 squared as the argument of a single log base 4. And again, here, I've used this trick many times in some of my other videos. So when you have a log and a single argument on the left side, a single log term, and a number on the right side, you can pull the base of the 4 here to be the base of the index on the other side. So the log will go away. So we have this. And that will be the base 4 to the power of 2. Okay? Now, it seems like we need to solve this equation. Okay? So I'm going to expand that. 12 minus 2x equals, this is 16 now, 4 to the 2. And expanding this already while being multiplied up there, I get x squared plus 2x plus 1. Again, if you know the complete square formula after the expansion, it would be faster like this. And expanding that all out, I get that, just following along, guys. Okay, and then seems like I'm gonna make the right side my main side and pulling the left to the right, but I'm writing the right side on the left here. I hope that's not too confusing. Okay, so minus 2x move to the right plus 2x, I get a 34x. 12 move to the right, I get a minus 12 there, so I have left with a 4 because 16 minus 12 is 4. Okay, so I think we can try factorize, but before that, I need to simplify. So dividing into everything by 2, I get 8x squared plus 17x plus 2 equals 0. Let's see if I can factorize this. Okay. I think we can try 8 and 1. Yeah, so 8x and 1x here, and the 2 and the 1. Because I see that 17 comes from 16 plus 1, so I tried that, and it works. Okay, so everything is fine here. We get 17 in the middle and 2 on the last term. And it seems like I get two negative value. No big deal. One of them must work. Now, some people think that when they get negative values here, and yeah, what I see is that they usually think is they're not going to work. But they're not going to, it won't work only when you substitute in the argument of the log and get a negative sign, right? So if we try take one of the argument, 12 minus 2x here, if we substitute that in, this will work because you get a negative and a negative, sorry, a negative multiply the negative here, you get a plus. So that's no big deal. And the other one also the same, and a minus, substitute there, you get a positive number. But if you check the other argument, okay, in the initial question here, well, 1 minus 1 over 8 plus 1 is still greater than 0, so that's fine. But not the minus 2 now. The minus 2 doesn't work because it's smaller than minus 1, so when you add them up, you get a negative value. So this guy doesn't work. That means x is going to be only equal to 1 minus 1 over 8, and that's the final answer. So the bottom line here, guys, you need to be careful when you find the answers for a log equation. You need to always substitute back to check if everything works, right? That's very important. Okay, number 7. So Jem pays money into a saving scheme A over a period of 300 months. So this is sequence, application of a sequence, right? Jem pays 20 pounds into scheme A in month 1, that, month 2, that. Yeah. So this seems to be arithmetic, right? Yeah, scheme A. Yeah, arithmetic sequence. Show that Jem pays that in month 100. Okay, so we know that the formula of the arithmetic sequence is an equals the first term a plus n minus 1d, n being the term number and d being the common difference. The common difference here seems to be from the first to the second term is 0.5, right? So the first term being 20.50 plus 100 is basically n equals 100. So we're going to subs that in. D is again 0.50, right? Just multiply that. Checking everything here. So this is A100, yeah? Which is equal to, so 20.50 plus 99 times, actually I can just do that already, right? So that's 50 minus 0.5. So I'm gonna get, ooh, interesting. I don't get what they want. Something went wrong. So 20.5 is the first. Oh, sorry. The first is actually 20. My reading. That's bad. Okay. Yeah. Yeah, it sometimes can be tricky to read everything in one line. All right. So yeah, this works now because 70 then minus 0.5, I get 69.50 pounds. Okay. All right. Yeah. Haven't used the money in pounds for a while, but anyway. Find the total amount that Jem pays into scheme A over the period of that. Total means we need to find the sum of the series. Okay, so that's Sn. We're going to use this maybe. So you can check the formula sheet, but I think I can remember that. So it's going to be that. So it's just 2n there. And then this will be multiplied by n over 2, right? Yeah. Okay. So that's the formula. 300 months. So that's n being 300, right? And a being the first term again. So 2 times 20 is the first term. Be careful. Yeah, 300. I'm just telling myself. Minus 1. D is the common difference again, 0.5. N being 300 and divided by 2. Okay. So I should need a calculator here maybe, or maybe I don't. So let's try that. So 40 times, plus a 0.5 multiply 300. So you get half of that. So it's 150 minus 0.5. Just expand brackets there. And this is 150. I probably need a calculator there, guys. So in the brackets, I have 190 minus 0.5 equal. Okay, so that's that. Then answer times 150. Yeah. So that is 28425 pounds. All right. Yeah, I think I'm happy with that. And then the next question says Kim pays money into a different saving scheme B, and now this should be geometric, right? Very expected. Okay. And in the model, the amounts Kim pays into scheme B increase by the same percentage each month, so that the months Kim pays each month is a geometric sequence. Okay. Given that Kim pays 20 in the first month as well, and 250 in month 300. So the geometric sequence is AN equals A times R to the N minus 1, where R is a common ratio and A is the first term. We don't know the common ratio yet, but we got two information where the first is A being 20. So I'm just going to write A 20 already because that's already known. Yeah. And the second information, we have 250 being at the month 300. So that's 300 minus 1. So we can solve for R in this way, right? So cut 0, I get R to the 299 equals 25 over 2. Gonna need a calculator for that, right? So yeah, so we can write this first. R to the 299, R equals 25 over 2 to the power of 1 over 299. Or if we want the decimal of that, we have to the power of 1 over 299. So that is just the value of R. That seems to be reasonable because we need something more than 1 to make it grow, right? I'm just going to stop there maybe. Okay. And that's our value of R. Use the model to calculate the nearest 10 pounds, the difference between the total amount paid into the scheme A and the total amount paid into scheme B over a period of 300 months. So we already got that for the first scheme. We just want the second scheme here, SN for the scheme B, right? So scheme B, the formula is A times 1 minus R to the N over 1 minus R. That's just the formula for the sum of geometric series. A is the same, 20 times 1 over R to the 300. Okay, let me see. So R to the, interesting. So R to the 299 is that. So R, yeah, okay, that's fine. I think I'm gonna use that, yeah. I thought I can play some trick there, use some trick. But anyway, N is 300. Divide by 1 minus 1.008483 dot dot dot, right? So because I already have the R here in my calculator, I'm gonna use it. So equal, store it as my answer. And then I'm going to do fraction 20 times brackets 1 minus answer to the power of 300. Don't hit the equal sign yet. Hang on, let me move that. This calculator is just a bit annoying sometimes. Oh, no. Okay, that's the top part. And then the bottom part, just hang on. 1 minus answer. All right, everything is good. So the sum is a bit different. Okay. So look, we have this. We have to find the difference between these. But yeah, use the model to calculate nearest the difference. Okay, so this is for B, sum of model scheme B, and this is sum of model scheme A. So we do SA because SA is greater, minus SB equals. Because I already have the SB in my calculator, I'm just going to hit equal and then clear. So we're going to take 28425 minus answer. So that is the answer from the calculator, but we're going to have to answer to the nearest 10 pounds. So that is 1060 pounds, 60 pounds. There you go. So that would be my final answer for that, for part C. Number 8. Number 8 now. Figure 1 shows a sketch of part of the curve C1 with equation that, okay, we have two curves, and then C1 and C2, okay. Using algebra to find the x coordinate of P and the x coordinate of Q, P and Q. So we need to equate them, right? That's trivial. Okay, so x squared plus 3 equals 13 minus 9 to the, 9 over x squared. Okay, so x coordinate of P and x coordinate of Q, so there are two solutions here. If we multiplied everything, hang on, before multiplying, we can do x squared minus 10 here. And I'm going to just move everything to the right side because I will do that anyway later on. So I do it now. Yeah. Multiplying everything by x to the 2, I get x to the 4 here. And then moving the term a little bit, you know, just, oh, yeah, I don't need to, hang on. Yeah, that's already the right location. Okay. And then 9 here is only left there because x squared canceled x squared. So again, we can already factorize in x to the 2, so I don't need to let anything be anything. You can also do that because it's like factorizing quadratic, but you are letting x squared be something else in that case. So see if I can factorize this. I think I get 9 and 1 there. Yeah, so I get 10 in the middle, minus 10 in the middle, and 9 for the last term, still equals 0 there. So because all of the x's should be greater than 0, so we have x equals 1 from that, and x equals 3 from that, right? So it's like if you don't follow, x squared minus 1 equals 0. I get x equals plus minus 1 here. And the other one is x squared minus 9 equals 0, right? So when you have two brackets multiplied to get 0, one of them, one or the other should be 0. That's why I get this line right here, right? So this is x being plus or minus 3 if you move to the other side and square root. But we only want positive value, so I'm just going to write that. Yeah. So maybe the x coordinate of P would be 1 and the x coordinate of Q would be 3 because they want you to specify that because here P and Q are in a specified order, P first and then Q. So that's why I put P as 1. Now question B, right? And that's A. Use algebraic integration to find the exact area of R. So that goes from x being from P to Q. Now, because we can see that C2 is above C1 in these bounds. So we're going to do integral y of C2 minus y of C1. Yeah, integrate that, where the bounds will start from P to Q. So x of P is 1, x of Q is 3. So that's just that. Okay. So that's the area I want to find. Yeah. So C2 minus C1 because C2 is above C1 here. So C2 is okay, so this is integral from 1 to 2. 13 minus 9 over x squared and minus the C1 function, which is x squared plus 3. So if I expand the minus into the function, I get minus x squared and minus 3 all together there. And don't forget the dx. Now, this will simplify to 10, right? So the first term, let's say 10, yeah, because minus 3 and 13 here simplified to 10. So I get a 10x here first, integrating already here. Okay, well, let's do this one. So this one basically is a minus 9x to the minus 2. So I'm integrating this. I'm adding the power by 1 and bringing it down to divide. So I have a minus 9x to the minus 1 over a minus 1. But a minus 1 with the minus sign in front, I get a plus, right? And then the last term here, minus x squared. So I have x cubed over 3, close bracket. And then the bounds would be from 1 to 2. So that is the integration. We want the exact area, so we're not going to maybe use a calculator. So, okay. Yeah, so my technique when I subs the integration like this, I'm going to do each term, not each set, by each bound. So each term means I'm doing separately for 10x, but I sub the upper bound and lower bound subtracted in the brackets like that. So that's first term done. The second term, 9 here, the upper bound is 1 over 2. X to the minus 1 is like 1 over x, so that's 1 over 2. Minus 1 over 1, which is 1. Don't need to write that. And then the other one, if I write 1/3 in front first, and then I sub x to the 3 as upper bound 2, and the lower bound being 1. So I get that. Yeah? It's like you write less by doing this, basically. So the first term I get 10. The second term here, a half minus 1, I get a minus a half. So that's minus 9 over 2. So this is in the brackets, 8 minus 1, which is 7. So that is minus 7 over 3. Yeah? All right. Let me use, no, I don't use a calculator there because it doesn't give me exact. So if I multiply 10 by 6, so that's 60 over 6, everything will be over 6. That will be multiplied by 3, I get 27. That will be multiplied by 2, I get a 14 there. So it's like I'm doing the fractions here. 60, so 27 and 14 added up together, we get 41. And subtract into the 60, we get 19 over 6. Yeah, just checking. Yep, I'm happy with that. So this is the exact area of that. Let's go ahead and do other questions first, see if we have anything left. Oh, that's still question 9. Oh my God. Question 9, show that the equation that can be written as that. Well, the first glance tell me that I should change a tan to a sine theta over cos theta, because that's the general practice, guys, when you see a trick question like this, because it's only in sine and cos here, right, mostly. And then if you move cos to the other side, you get that equals 3 cos squared theta. And because the question only wants in the sine form, I'm going to have to use the identity, which is sine squared plus cos squared equals 1. So if you move sine to the other side, you get 1 minus sine squared theta being equal to cos squared theta. Expanding everything, I get that. Move everything so that the sine squared term becomes a positive. So I have 3 sine squared here, and I got to move to the left. So this is a plus 2 sine theta, and 3 would be a minus, right? So that is as required. B hence solve. All right, so we're going to solve some trig function here. It's fun, guys. So note that you compare, when you see this, right? This might appear in P3. It actually did this year. So you got to compare the angle, right? Yeah, everything is the same if you compare the first form to this form. It's just the angle. if you map theta to what you see down there, 2x plus pi over 3, this is just our substitution. So after you solve for theta, you plug theta in this equation and you're going to get x because you want x. But you gotta don't modify the range because we have been given that x is in that range, right? This is very important because sometimes you can get too many or too few answers without looking at the range of x. So if we modify the range, we multiply by 2 first, we get a minus 2 pi, just step by step here. And then we add a pi over 3, so minus 2 pi, add pi over 3, that would be a minus 6 over 3, and a minus 5 pi over 3, right? For the left part. Just making sure if I got everything right. Yeah. So that would be just 2x plus pi over 3 there, less than. So this is 2 pi, which is 6 over 3 pi, plus pi over 3. So that's 7 pi over 3, right? Yeah. So that's the actual range we are solving for. And yeah, so because the first equation for theta maps perfectly with this, where theta equals that. So we want to solve for theta on the second equation instead, because it's easier. That's why we already derived that. So we solve that. Okay. Seems like I can factorize maybe. So I'm going to try that. Factorize without letting anything be anything else. Just factorize it like this. You can use this technique, guys. It's useful. So seems like, well, that doesn't work. I cannot factorize. Maybe not. Yeah, no, I don't think so. Hang on. No, I don't think so. 3 and 1. No, maybe not. So I'm just gonna delete all that and maybe use a quadratic formula because I don't have any quadratic function solver. Okay, so minus b plus or minus square root b squared minus 4ac all divided by 2a, yeah? Okay, so in the square roots, we get, so that's all positive there. 4 times 3 is 12. 12 times 3 is 36. 36 plus 4, because 2 to 2 is 4, is 40. 40 is basically 2 root 10. So this is minus 2 plus or minus 2 root 10 divided by 6. And of course, we can cancel the 2 out, so we get a minus 1 plus or minus root 10 or divided by 3, just simplifying that. Okay, so that means we have 2 roots for the sign, but let's check. One of them maybe doesn't work because I'm just curious. Because if sign goes below minus 1, then it shouldn't work. And it does go below minus 1. So sine theta here only is minus 1 plus root 10. Only. Okay, just so that they know that I discard one of them. So we're only going to take this root where that is a plus instead. So which is 0.720759 blah blah blah. Now we're going to solve the quadrants for this, looking at the cast diagram. Because sine is a positive value, so we are only looking at the first and the second quadrants. Okay, and that being the basic angle. I use this term all the time. Okay, so the basic angle would be arcsine of that. Yeah, so because I already have that stored in my calculator, I'm just gonna, and this will be in radians, just to be careful. So I'm gonna change that to radian first, and then I do arcsine of my answer, right? So that gives me about 0.804896, blah, blah, blah. Okay, that's my basic angle. Now, we want to solve for theta, where theta is in this range, because we derive for this whole lot. Yeah. And that is basically theta. So theta sits here. That means we can't go beyond 7 pi over 3 and below minus pi over 3, minus 5 pi over 3. I'm going to be in trouble. Yeah, okay. Let me convert that into 7 pi over 3. So that is, just for reference there, that is 7.33. And this is negative 5 pi over 3. So that is negative 5 to 3. Let's say 2, 4. Yeah, that's already 3 significant figures. Okay, so we want these two roots. I mean, these two lines where we have to measure for multiple answers. So here I say theta would be equal to, let's use the same color. Okay, so let's check for the positive answers first. We cannot go beyond 7.3. That's about a bit more than 2 pi actually. So the first one is that, yeah. I'm gonna do 4 significant figures first just to be safe because we need to turn it into 3 later. So I'm gonna do 4 here. And the next one, that would be, I'm already out of that. So it's gonna be just pi minus, yeah, 0.8048, maybe 49, right? Yeah, that should be fine. This is 2.3367. Yeah, just 4 decimal places there. Yeah, I'm gonna change to the right significant figures later. And if we try add this to 2 pi, see if it's over 7.33, right? So 0.8049 plus 2 pi, that is not over the limit yet, right? So we got to take another one here, right? So when you got these two angles first, you got to try add 2 pi and then 2 pi for both of them and then see if it exceeds. But when I add 2 pi to this one, it doesn't exceed it. It gives me 7 point something, which is less than our actual upper bound. So I still have to account for this new one, which is 7 point. Yeah, so okay. I think I should write these down, right? Okay, yeah. Let me write these down just for the working. So 2 pi minus 0.80, that, okay, equals, what was it again? I lost it. Hang on, let me, okay. You know what? Let me move my whole thing here to the left a bit. Two pi minus that, the basic angle, I just write BA equals, just write OR here. So that would be, yeah, what was it? Okay. Here I have 2 pi plus 0.8049. I get 7.0880. So I can stop there. So just that one, 2 pi. Sorry, it should be a pi, right? It's not 2 pi. Pi, a pi minus 0.804896. Yeah. So here, this is not 2 pi. It should be a pi. Sorry. Okay. 2.3367. Okay. This is 0 here. So those are the 3 roots for the positive side. Okay. I still have a negative to consider. Now look, I'm not gonna go this one adding 2 pi because it is quite obvious that it's gonna be over 7 point something. So then the negative roots, because we can still go to the negative side here. So the first one is gonna be that one, right? Negative clockwise. So that's gonna be negative of pi plus, yeah, if we go here, pi, and then plus the basic angle. So that's gonna be minus. So I'm just going to do pi plus 0.804896. So that's negative 3.9469. Yeah, just stop there. Okay, or, and then the other one is, oh, hang on. The other one would be that one. So it's 2 pi minus, right? So I can do 2 pi there and minus. Yeah, that same thing. But we just add a negative sign. So this is minus 5.4782 or 3. See if it's over the limit. It is a bit over the limit, I think, because I think if we remember, we round this up, didn't we? So 5 pi over 3. Yeah, this is actually a bit less than what we have here for the second negative root. So we're not going to take this, right? This is out of the range. So these are the only 4 answers. That means the actual answer we want, which is x, is going to be equal to all the theta values. Yeah, you rearrange that to get x. So all the theta values minus pi over 3 divided by 2. Yeah. Yeah, just rearranging this, right? So I'm just going to go from the first one. So we can just do 0.8049 minus. I'm going to keep the same thing here. I'm just going to change the first number there. All right, so this is the answer for the first one. Minus 0.121, 3 significant figures. And then we have here, change it to 2.3367, 0.665, no, 645, almost make a mistake again. All right. And then change this to the third one being 7.088. So I get 3.02, 3 significant figures. And then the last one, a minus root 3.9469. I get a minus 2.450. Okay, so that's everything. Ooh, 3 significant figures, all of them. Right. If we want to check, we can check this later. But now I'm just going to go ahead and do number 10, which hopefully is the last question. Hang on, is it? Is it the last one? It's not. Oh, that's the 11th question. I need to hurry up now, guys. Okay, number 10. Yeah. Circle C has equation that find the coordinates of the center. Okay, so we just complete square separately for the x and the y. I'm just going to bring the x term here nearer together first and the y here being closer together like that. And maybe I'm going to pull 209 on the other side, becoming a negative number. And then completing square here, if we add 4 for the first set, we're going to have to add 4 on this side too, because we are doing an equation here, so we got to do on both sides. We add 4 there because it can become a complete square for the x. And then we're going to add, what do we add here? So if we divide minus 30 by 2, that's going to be 15, right? So that's basically 15 squared. So I add 225, which is from 15 squared. So we add also 225 right here as well. So in totality, the left part is going to be x plus 2 squared plus, this is going to be y minus 15 squared. Because the minus 15 comes from minus 30 divided by 2. That's easy, yeah. And this is 15 squared, minus 15 squared. That part is going to give me 229 here for the latter 2 terms. And then that's going to be 20. Because 229 minus 209 is 20, yeah. So the coordinate of the center C is going to be minus 2 and 15. And then the exact value of the radius is going to be that square root, right? Which is 2 root 5 if you do the surd there. Okay, so I'm done with A. Next, B. The line L has equation that where M is a constant, given that L is a tangent to C at point P. Show that. Okay, so we have that equation where M is a constant. And line L is a tangent to C at point P. Okay, so when we have a circle and a tangent, we know two things. First, they intersect here, and second, the gradient of the gradient. Okay, so the gradient of the radius drawn to the tangent will be perpendicular to the tangent. This is circle theorem. So we know that this point is what? Minus 215. And this point, let's say we don't know yet. Let's call it xy. Now, the important thing here to also note that because this is line L, and line L follows this equation y equals mx plus 1. So that means we can instead write mx plus 1 instead of y, right? So I can also say that my coordinate here is x and then mx plus 1. Just to cut out one variable, right? We have one less variable there. So we find the gradient of the radius maybe first. So gradient of the normal is going to be equal to 15 minus mx plus 1 here altogether. So I have a both minus that. And divided by minus 2 minus x. Okay. And this gradient is going to be perpendicular. So that's equal to 1 over m here, because we already given with the gradient of the line L. So that's m. So perpendicular, we do 1 over m and put a minus sign here, 1 over m. So that's basically it. So, and then also, okay, this is one of the equation. All right. 3 marks. Okay. Am I thinking too much? This is not what I'm going to get, is it? Let me think about that a bit. Probably not. Okay. What if I substitute y equals mx plus 1 here to the y here? Is that a better idea? Okay, look, I'm gonna subs y equals mx plus 1 to the equation of the circle first. Yeah. Because it's tangent, that means it intersects as well into C. So I get x squared, but I'm out of x squared there. Okay. Okay. So we know that. Oh, hang on. We also have the radius. We know that the radius is 2 root 5, so we can find the distance there. I forgot about that. Okay, so x minus 2. Well, that's just basically circle equation. Yeah, that's basically circle equation. Okay, so x is 2 minus mx plus 1 squared plus 4x. Yeah, I'm substituting just as I say that. Minus 30 mx plus 1 plus 209 equals 0. Yeah. I don't like this. X squared plus m squared x squared. I'm just expanding this. Plus 2mx. Yeah, 2 times the first times the second. Plus 1 here, expanding all out. I need to hurry up a bit. So I'm just going to cut the explanation for the algebra a little bit. Ooh. Oh, okay, that's fine. Okay. So we're going to have to bring this equation down into play too, somehow. Let's see if I can do that. But before we do that, we simplify first, all right? So that will cancel with that. I get minus 28 mx. And And then there's just a 4x here. All right. And 1 and minus that. So I get minus 29 again. And then would be minus, no. Okay. I'm out of brain right now. I need a calculator. Okay, so I get 180 there equals 0. Now let's look into detail for this one. So if I move m cross multiply there, what do I get? I'm gonna get 15m minus m squared x minus m equals minus 2 minus x. Multiply that, I get 2 plus x. That's horrible, guys. Um, hmm. Okay. This is not good, not looking good. Tangent to C at P. Hence find the possible pairs of coordinates. I think I need to use a bit of imagination more. I didn't think about the graph at all. Let me try draw a graph. So we have minus 2 here and 15 up here. Okay, and then that's the center. And because the radius is a little bit more than 2, so I'm going to draw my circle like this. This is minus 2, 15. And then, yeah, the line y equals mx plus 1 doesn't tell anything about m. M is a constant, so we have a 1 here being the y-intercept of the line. Tangent, so we have these two possibilities, and the other one being that. All right? So the tangent are there, and we need to show. Okay. So this is going to be perpendicular, of course. Yeah. All right. So we know that this is 0, 1. Can we do anything with that? We know that this is radius, which is 2 root 5 there. And this is a perpendicular angle. We draw this line here. What do we get? Not anything. Okay. This one is tricky, guys. I can't really show that. Okay. You know what? I'm just going to skip to do C. I'm out of time now. I need to do another question after this. So we need to solve that. So I'm just going to factorize the m there from the previous part. And then is that 2 and is 2 and 11? Yeah, 2 and 11 works. So I have a no, hang on. 2 here, 11 here. No. Ooh, oh yeah, wait. 2 here, 11 here. My bad. So it's going to be 11 here minus and plus here for the 2. So that's why I get a minus 7 there. So m is going to be 11 over 2 or minus 2. So that's the m values, and find the possible pairs. We can use what we got earlier. So possible pair of p coordinates. So that means the y, the line, the tangent would be mx plus 1. So 11 over 2x plus 1, or y equals minus 2x plus 1, right? And well, we probably got to solve for the coordinates of P. Yeah, because it's tangent at point P there. So there are two scenarios there. Okay, I think I'm gonna plug M into here and so forth. Yeah, so I can use this one. Maybe I'm gonna make use of that. Okay, so M is 11 over 1 minus 11 over 1 squared. X minus 11 over 1 equals 2 plus x. We can solve for x, right? Okay, so I'm going to be quick here because I'm out of time. So 15, 11 over 2 minus 11 over 2 minus 2 on the right. I move x on the other side. And if I sum up the coefficient here, I get 11 over 2 squared and plus 2 moving down. Wait, hang on. Yeah, factorizing x out, I get that. Just checking. This should be a 1 instead. Yeah, just 1x. All right, so that's my first x in a fraction. 15 times 11 over 2 minus 11 over 2 there. I'm going to do bad in this paper, guys. Plus 1. So this is 2.4 magically. And the other one, again, repeat the same process. 15 minus 2 minus 2 again, minus 2 over minus 2 squared plus 1. Because I already rearranged, so I'm quite safe doing that. And we're going to just change that to a... Oh, no, hang on. So that's minus 30 and minus 4. Just wrapping up the constant there. This is just minus 6.8. So that's one answer. That's the other answer. Oh, the possible pairs. Oh, come on. We got to find a y as well. So y goes... Right, so this is y equals, putting the x into there. So we get 1.2. 1.2 is 1.32. Just substituting into the corresponding linear equation. So 1.2, yeah, 1.32 plus 1, so 2.32 there. And then the other one would be minus 6.2. So that's 13.6 plus 1, that would be 14.6. Okay, so these are my answer for that. I'm gonna go do number 10 now. Out of time, out of time. Wait, is it 10 or 11? 11, sorry. Prove by counterexample that that statement is false. N is a prime number, then N is also a prime number. Okay, so let's say N is okay, so I need calculator here, 3 to the 5, and then plus 2. Is that a prime number? Yeah, it's not. So if N equals 5, which is a prime number, then 3 to the 5 plus 2 is 2 or 4, 5, divisible by 5, therefore not prime, therefore false. Okay, that's just wrapping up, guys. I'm out of time. Use proof by exhaustion to prove that if m is an integer, this is not divisible by 3. I need page. I need a page. Okay, m is odd. So for odd and for even, right? So 2k plus 1. And then even. So m equals 2k. So if m is an even, and that is not divisible by 3, not divisible by 3. So let's say it is 3k plus 1, and this is 3k plus 2. Yeah, there are two cases because 3k would be divisible in 3k plus 1. So m squared minus 1 here would be just expanding that, 9k squared plus 6k plus 1 minus 1. So that would be 3 and then 3k squared plus 2 k. So this is multiple. This is yeah, so divisible. I'm just going to do this one first. Again, 9k squared plus 2 times that's 12k plus 4 minus 1. So you can bring 3 out. So that would be 3k squared plus 4k plus 1. All are divisible by 3. Therefore, if m is an integer that is not divisible by 3, then m squared minus 1 is divisible by 3. That's it, guys. I just have 2 or 3 minutes to do that, so I didn't manage to do that. And my time is up. I'm gonna mark my paper now. All right. Okay, let's mark the paper. This is the mark scheme of October 2024 P2. Let's see how well I did. I didn't think I'd do well because I didn't have time to check much. But let's see if I'm lucky. All right, see if I'm lucky. 30.9, 90.9. So far so good for the first one. Second question, let me move screen a little bit. So the second question, A, I proved that to be 7. K is 15. That's 1125. That's good. Number 3, what's that? Oh yeah, just proof there. That's just A. B is, oh no, yeah, this is what all right, something went wrong, guys. Okay. So, and that is when I solved simultaneous and got it wrong. Wait, this is 5a, not 5/2. Okay. Yeah, this is when I substituted this wrong. Oh no. I substitute 5/2 in, right? And they do that. Okay, that's weird. But that's still the same equation. Oh, wait. No. Wait, if I add them up, I should get a minus. Oh, I add them up, I get a minus. Oh, no. Man. All right. I think I lost 1 mark. Just got a method mark there. And see if I have a chance to do this one right. No. Yeah, there's a follow-through mark because I got B wrong. So I think I get a method mark for that. Yeah, long division. Yeah. So I lost 1 mark for that for the accuracy. Now I lost 2 marks for this. 2 so far, guys. See if I lose more. Okay, 4a, 9/4, good. Okay, and that is just, yeah. For ci, that should all be fine. X, yeah, I'm just looking at the second derivative there. Yeah, that should all be fine. Yeah, this is a minimum because I prove it to be greater than 0. Yeah, I think I nailed that range. So I'm quite safe here there because I got it down. Number 5. Okay, all 3 term corrects. And B minus 24/5. It is a bit exciting, guys, to check my own paper, right? Normally I check students' paper and it's not that exciting. Well, it is sometimes because I hope that they will do well, but anyway. So this is right, and then I got that down. So I got that to be the answer. Number 7. 69, yeah, that's as required. That's, and that, yeah. Number 8, 1 and 3. Wait, okay, let's check A first. Number 8, A, 1 and 3. Yeah, that's A actually. Wait, hang on. Yeah. B6. Ooh, B is wrong. B is wrong. B is wrong. Okay, I get that method and hopefully that accuracy too, because there doesn't seem to be any difference here between the methods. So yeah, so that's fine. Yeah, let's see if I integrated everything right. So basically, yeah, 10x there, 9/x, and then yeah, so this is 2 marks. Got it. And then DM1 is just substituting the bounds. The bounds. Oh no. How stupid I was. Look at that, guys. Look at that. But anyway, I think I got that mark. So okay, if the integration or limits are incorrect, then the substitution is not shown explicitly, then you may need to check. So I'm not going to get that mark because they require you to substitute for the right bounds. But I did not substitute the right bounds in. Yeah, 4 marks now, right? I lost 2 marks here and another 2 here. And I'm gonna lose more. I'm gonna lose more, I bet. For number 9. Okay, I nailed that part. Number 10, sorry, actually. See if I got this right. Okay, so that is fine, that is fine, that is fine, that is fine. Phew, okay, at least I nailed this one. Spend some time on that one, right? And number 10. Okay, so let's see. This one is a troubling one. Okay, yeah, this one is fine. Radius is that. Now the B, how did they do the B? All right, so yeah, I can't prove that. Okay, so they actually substituted like I did here. So I should get some method, right, guys? To be fair. Yeah, yeah, I did. I did get the method there. I substitute that. And then I expanded. Oh, I forgot about this discriminant because the answer should only be 2. Damn, I forgot that discriminant. So I lost 2 marks there. Now already 6. Okay. I hope I'm getting this right. Really? Okay. So yeah, 11/2 and -2. There you go. And so substituting everything in 2.4, that is 2.4. Is that, what is that? 2.32? Probably not. Did I substitute 2.4 in there? Yeah, I did. So what is, hang on. 2.4, 1.2. Oh, that is not 13. Oh, it is 13. Wait, what? What did I write here? I can't read my handwriting now. This is wrong. Okay, so let's read the mark scheme, what they say. Okay, but I think I got this method mark because I just did exactly that. So, oh, but the other X is wrong. Yeah, that was too rushed. But let's see. Okay, C method mark, the second method mark, use at least one of their values M to attempt one position. Okay, yeah. At least one correct point, but I got none correct. So I don't get that. I lose 2 accuracy marks. That hurts. That hurts so much. Well, I hope I nailed 11. Hang on. Yeah, this is too much. Okay. Yeah, I got the same number as theirs. So yeah, false, not prime. Wait, do I need to say that? Yeah, I probably do, but okay. Correct calculation for the value, there must be some reference to not being prime. Yeah, not prime. Or they show that the number is divisible. The value they have chosen must be clearly. Yeah, I think I got it right. Yeah, I didn't lose any mark. And then next one here, yeah, I do that and that. I think I nailed that part. I nailed that part fine, just in time. Oops, I've got a bracket there, but I hope that's fine. So both multiple of 3, I just wrote divisible by 3, yeah. Okay, and then I concluded that. So I lost 6 marks in total. -2, -2. Wait, or is it -8? Hang on, -2, -2 here. And -2 here, 6 now. -8. I lost 8 marks. So that's 67 out of 75. That hurts, guys. That hurts. But that's honest. That is just the live walkthrough. So I hope the correction when I pull out the video will be helpful. And yeah, this paper is hard. It's kind of like 11 questions, but you got to do it in an hour and a half. So I probably spent too much time talking in the first questions, like, so I should have maybe speed it up a little more. But it was tough. And I did make silly mistakes in the signs and in the numbers, even the bounds of the integration. So even I still make silly mistakes, guys. So you have to try your best to be careful. That's always what I tell my students. I know that it's not possible to avoid, but you can try your best to avoid them, to make less of them, maybe. All right. And that was it. So I hope you guys keep studying. See you in the next video. Bye.